that we can start it right off. So when you go to Algebra 2 Google Classroom, you can see that there's a stream, and probably this is the only way you have seen your work, but that's more confusing if you are looking at your work on the stream. So go to classwork, okay? And there will be all this assignments that I have given you after this COVID-19 closure, okay? You got to go down all the way down to see the first assignment, view more. You probably have to click view more like 3 times. Okay. And there you go. That's assignment 1 after COVID-19 closure. And there are 21 students who haven't done this. So I invited them all, but only 2 of you are here. Okay, Karen's here. I think that Karen did it already. Oh, Jasmine out. What's going on? Okay. So I'm going to go over this packet part 1, and Diamond, I'm going to share this later, but also I encourage you to like write down this so that like what I'm going over is like your answer, and this is going to help you out to finish your packet. So if you have a pen or a pencil and your note, just bring it and then write it down as you go.
Miss Park, I kind of don't have a notebook,
You
but
don't? Okay.
no,
And you don't have any papers?
no.
Okay. Okay. So I'm just going to, since somehow you're the only one, Jasmine left, so I'm going to just walk you through together. Okay. So first of all, I need you to complete the sentence. Do you see the bottom line here?
Mhm.
Okay. So the bottom line for product rule, the law is, the rule is that x to the mth power times x to the nth power is equal to x to the m plus n. Okay. So what are we doing with x to the m and x to the nth power? Are we
Aren't
adding?
you?
Are we?
You would add the exponents.
You would add the exponent. Okay, so let's fill that part out. So you add the exponent. But what were we doing here?
You were multiplying the constants.
Right. Very good. Multiplying. So here you have to write down multiplying. Okay. And another thing that I want to point out is when okay, so how do we call this x in this so we call m as an exponent. What is x?
One.
1x. That's going to be coefficient, but what is x? Like there's exponent, then there should be, let's start with b.
A,
B.
a byproduct.
Ba- Base. It's
Uh,
base. And the and x, if the bases are the same, then when multiplying we add the exponent. If the bases are different, like for example, if that was x to the nth power times y to the nth power, do we add the exponent, or do we don't do anything? What do you think?
wouldn't if the bases are
Bases are
different?
different. Hmm.
Wouldn't you subtract that? No, you wouldn't do nothing.
You wouldn't do anything. Very good. Exactly. So what I need you to write down there is going to be the same base. The bases are supposed to be the same. Okay. So these are what you need to write down on bottom line. Okay. And now practice questions. 7 to the fifth, 7 to the third. When you multiply, what do we do with the base? Do we change it or do we keep it the same?
You keep it the same.
Very good. And what about the exponent?
You would add them.
Add them. It becomes
7 to the eighth power.
very good. And the way that you can put eighth power is control and then dot. Control dot. It will give you the exponent and then I put 8 there, okay? So that's what you need to put as the answer, x to the eighth power. Or you can just do 7 to the eighth power like that. That works as well, okay? Next one that I want to go over is this question. 11 to the 2 over 3 times 11 to the 7 over 3. Again, what do I do with the base?
You would keep it the same.
You would keep it the same. Very good. And what do I do with the exponent?
Uh, wouldn't you just add the two numbers? Wait, the numerator, since the denominators are both the same,
Okay. So what would that be?
it would be 9. It would be 11 to the, well, to the third, because you'd get 9/3, but you can simplify that to 3.
Perfect. Very good. So that will be 11 to the third. Okay. All right. So if it's hard for you to write down your answer like this on your doc, Google Doc, then you can write it on your paper and then take a picture of it and then send it to me, okay?
Okay.
So that's the product rule. We're going to move on to quotient rule. Now, quotient rule is when you divide. X to the mth divided by x to the nth is equal to x to the m minus n. So what should I put here when we do what? We're not multiplying. What are we doing here? X to the mth power and then what?
When you divide,
Right, very good. So when dividing two exponential term with, what about the bases? Are the bases are supposed to be different or the same?
they're supposed to be the same.
Exactly, same base. Then what do you do when you divide?
You would subtract the exponents.
Very good. Okay, subtract the exponent. All right, now practice question. So we got what 5 to the third divided by 5 to the second. What do I do?
It would be 5, just 5.
5. Why?
Because 3 minus 2 is 1, so you don't really have to put that exponent there.
Very good. Perfect. 5 to the first is going to be 5. Very good. Okay, now moving on to the next question that I'm going to go over is this, the one that with the fraction. 5 to the 9 over 5 is equal to 5 to the 4 over 5. Again, what do I do with the
You
base?
you would keep the base,
Mm-hmm. Which is
and it would
5.
be 5 again, because you would keep the denominator of the fraction,
Mm-hmm.
which is, that's 5.
Right.
Yeah, which is 5, and then 9 minus 4 is 5.
Right.
So that fraction itself will give you 1, but you don't need to put it.
Very good. So, like you said, 9 minus 4 is 5. 5 over 5 is 1. So it's just 5. Very good. Okay. I wasn't going to do this part, but just quickly, if the bases are different, what do we do again?
You would divide them.
If
No,
mm, okay, can you divide 2 to the eighth power by x to the fifth? If the bases are like different like this, what do you do? You actually answered earlier correctly.
I did.
You
Oh,
did. Yeah, when the bases are different.
man, I forgot it that fast. Wouldn't you? Wouldn't you?
You can't say anything because you don't do anything. You
Oh,
shouldn't be doing anything. Yeah. You said you do nothing. Yeah. So that's what you need to put here when you write down the answer. 2 to the 8th and x to the 5th. Since the bases are different, you say do nothing. Okay? All right. Now, power to power rule. Power to power rule is when x to the nth power and then to the nth, like when you have a parenthesis and then outside of the parenthesis you've got another exponent, then you just have to multiply them. Okay? So what are we supposed to do with these exponents? It says x to the 1/2 to the 6th power.
wouldn't you wouldn't you multiply the exponents so you have 1/2 times 6/1, which
Mm-hmm.
will give you 6/2, and then you simplify that. That will give you 3. So your answer would be B.
Perfect. Very good. 6/2. Okay, so it will be the b x to the 3rd power because it's going to give you 6/2 and it will be simplified into b. So you are going to highlight this like however you want. We can, yeah, I'm going to skip that part. You know the answer, okay? And the fractional exponent, when you got like cube root or square root, like then it will change it into fractional exponent. It will turn it into fraction. So for example, if you got square root, say, okay, let's just give you an example. If you got square root of x, then this can be changed into x to the power, but you can see that x right next to x, there will be invisible 1 as an exponent, right? So that exponent becomes 1, and since it's a square root, which will give you 1/2. So it will be x to the 1/2. Okay?
Okay.
And so it's vice versa. Here's the example, x to the m over n power. Then that you can change it into n root of x to the m. So this exponent right here becomes the numerator, and nth root, this number outside, becomes your denominator of the exponent. Okay? Okay, Simon, let's change this into this. Okay, so what should be outside? What kind of root do I have to have? Is it
A square root.
okay? What do we see on the denominator in the exponent? It's hard to see.
I feel
It's
like it.
four. It's 4/3.
Okay, so it will be 3,
3.
and then you'd
And
have 27, and then you'd have 4.
the fourth. Very good. That's it. Okay. And yeah, that's what I need you to do. If this is in this form, then I need you to change it into like fractional exponent. If it's in fractional exponent form, then I need you to change it into this one. Okay?
hmm
All right. Do nothing. All right. So it says over there, when the bases are different, what do?
Nothing.
Nothing. So what do you put here?
This wouldn't it be the same thing? Oh, do
Yeah,
nothing.
same thing. Yep, do nothing. Or you can leave it blank. Then I will understand that you know you shouldn't be doing anything. Okay. And these are like combination of all those four different properties. So if I start off with this, what do you think that you have to do?
So you have to. Wouldn't it be? I
Mm-hmm.
know.
Mm-hmm.
I know you would keep your bases the same,
Right.
And I know it'll. I know you have to do something with the exponents. I just don't know what.
Okay, so let's break down. I see that 2 to the a power and then times. So that means nothing in between here, right here, right? It means that multiplication, right?
Yes.
And 2 to the third to the b power. So let's take a look at the second part here. What kind of rule would it be? 2 to the third to the b.
It would be the one. No, not the one we just did. We had product rule, quotient rule. I feel like it would be the one where you have to you would have to multiply that. So it would be 2, 3b.
3b, very good. And now we're multiplying these two together. What do we do with these exponents then? Like I said, you keep the base.
When you have to, I feel like it's a 1 next to that a.
Mm-hmm.
So wouldn't you add the 3 and the 1? So that would be 4ab.
Okay. Can you tell me if that was 1a plus 3a, what do you do?
You would keep it and it would just be 4a.
4a. And what do we have right now? A and b, right?
B.
Are they like terms or not?
Not like terms.
Not like terms, so you're just going to keep it as it is. Just put plus sign in the middle. You were right about it. You're adding them, but you cannot combine them together because they are not like terms. So you just put a plus 3b. That's it. And that's your final answer. Okay?
Okay.
All right, number 8. Again, this is combination of two two rules. So what do you think that you should do first?
Wouldn't you keep the bases? You'd have y, and then
Mm-hmm.
you would have to multiply. You would keep 8.
Okay.
Oh, it would just be y to the
Y
8.
to the 8. And what about the denominator? What do you do with this?
You would keep the y, but 5. Oh, wait, you're multiplying that. Oh, it would be y8 over y to the 15th.
15 is right. You have to multiply them. And what do you do now?
You'd still keep y.
Okay. What about the exponent?
You would subtract them,
Mm-hmm.
and it would be y to the 7th.
7th? Did you subtract what did you subtract from? What minus what you did?
15 minus 8.
15 minus 8. Okay. Which one is on the top?
8.
So, and which one is in the denominator?
15.
Okay, so what should come first? 8 or 15?
8
8. So 8 minus what?
minus 15.
15. Okay, what does that give you then?
-7.
-7. There you go. So you need to be careful about that. It's like we don't want to make negative, like I think that's like our like natural instinct that we don't like negative numbers, but you need to keep it as it is, 8 minus 15, so it's going to be -7. Okay? Well, I did it wrong. So 8 minus 15, -7. Okay? All right, number 9.
Is that what number is that?
5, fifth root of p to the 8th power.
So it would be p
Mm-hmm.
5 over 8.
5 over 8.
Yes.
What is supposed to be the denominator?
Oh, it will be 8 over 5.
8 over 5, why?
because you always put the denominator on the outside of the square root. You put the
Okay.
numerator next to the base.
Yeah, which was the exponent. So exponent goes to the numerator, and the roots, nth root, fifth root, this one is. So fifth, that goes to the denominator. Very good job. Okay. This is actually way faster than I expected. Great job, Diamond. I think that I'm going to give you like a whole lot of props because you are doing really well and you're on time. You actually were like earlier than 2:30. So, yeah, keep it up and I'm actually going to give you extra credit as well. That's what I announced already. So, keep keep it up, Diamond. All right. I didn't highlight this one, but I need to go over this as well. So let's try to do this. This is about discriminant, and I thought why not going over this because you did this in quarter one, I think, and this probably is going to come up during your ACT, maybe. And you really need to know what this is, right? So I'm going to um, ask you what you need to do first here.
Um, what I'm getting at from the example on the top is you would do. I have to sneeze.
Yeah, this has been a long time ago that you have to do this. So
Uh, you would have to do since you have your square, which is since you have your b squared, which is 3x squared,
mm-hmm.
you would subtract that from 5x.
Okay. 3x
And
squared minus 5x. You would do that.
yes,
Okay. Um, well, then
yes.
what do you get?
Wouldn't it be 2x squared, right? No, no,
Okay. So another question. X squared and x, are they like term?
no,
No. You say
yes,
no? Okay, then can you combine them?
no,
No. So can you subtract 5x from 3x squared?
no.
Okay. Then we can't do anything about that.
I got it. Wouldn't you have to
Hmm.
do something since you would leave 3x alone because you have to use that later on in the problem? Wouldn't you cancel out the 5x? So it would be it would be plus 5x, and then um you put the other 5x next to the under the 9, and so you
Okay. Okay.
cancel.
So I think that's, yeah, okay. So you're trying to isolate x squared. That's what you're trying to do, right? All right. I think that's, I would say that I wanted you to go back and you went all the way back to algebra 1 just now. So that method is valid if you have just one x. Like if that was like 3x and if you're looking for x value, then you can isolate x. But whenever you have like squared, then you cannot isolate x that way. So here's what you need to do. First, before you do anything, you need to know that we need to change the form into a x squared ax squared plus bx plus c equals to 0. Okay? These, from the discriminant, you can see that b squared minus 4ac, right? That
Yeah,
BAC we're coming from like in this form. You have to make everything and equals to 0. So what we need to move is not this negative 5x, but what?
the 9,
The 9. Very good. So you need to subtract what from both sides?
the 9.
Very good. So if you subtract 9 from both sides, Then what do you get?
You get 3x squared minus 5. Wait,
Hmm.
the 9. So that would be minus 9. You have 6x squared minus 5x equals 0.
Okay,
Right?
what did you do?
I sub I canceled out the 9. So since 9
Okay.
was positive right here,
Hmm.
I
Right.
subtracted it.
Right.
Oh, you
And
have
and is there any like term with 9 on
no.
this side? No. So what should I do? Can I combine with any of this or just put 9 separately?
You'd have to put 9 separately.
There you go. Okay. So after you subtract 9 from both sides, you should get this. And now you know what A, B, and C are. What is A?
A is 3x squared.
Okay. A is the number in front of x squared. So without x squared, you just put the number, like coefficient of x squared, which is
3.
3. So A is 3. B,
B would be negative 5.
very good. I'm glad that you said -5 instead of just 5 because a lot of students, forget about the sign and just say 5, but it's -5, like you just said. Very good. And C?
Would be negative 9.
-9. Very good. And now all you have to do is plug this number in here in D, b squared minus 4ac, and then find the answer. So let's do that. If you have a calculator with you, then you can use the calculator. So first of all, b, which is -5, -5 squared. What is that? -5 squared is -5 squared.
Wouldn't that be negative 25? Wouldn't it just be 25?
25. Why not -25?
Because both of the negatives canceled each other out.
Right. Negative times negative is going to be positive. Very good. So it's going to be 25 and minus 4 times A. A was 3. And C, which is -9, you said. So you said 25 and then minus. Okay, what about this part? -4 times 3 times -9.
3. Negative 4 times 3. That would give you negative 12. And then you would multiply negative 9.
Mm-hmm.
Ooh. It would be one, then it would be, both of the negatives would cancel each other out. You would get 108. So it would be 25 plus 108.
Very good job. Very good job. So it will be then 25 plus 108, which is 100.
That would be 133.
133. Okay, now that I got 133, I'm trying to tell whether this gives us real solutions or non-real solutions. If your discriminant is positive, what does that tell us?
It's real.
It's real. There you go. What if I got 0? Is that real or non-real?
Non-real.
Okay. What if you got negative number?
It would be it would be non-real.
Let me ask you about 0 again. Would it be non-real or real?
0 would be non-real.
0 will be real, but you're gonna, and yeah, so you need to be careful about that. 0 or positive numbers, real number, real solutions. And when you got negative number, then it means that you got non-real solutions. Got it? Okay, so that's what you need to do with these. For example, with this question, you would have to add 6 on both sides, and then you would identify A, B, C, right? For this one, you would have to what? How do I get rid of this, you think?
You would have to care. No, you would focus on. Yeah, you would just focus on 2x plus 11. So you would you would do something and it would cancel both of them out.
Right. How do I cancel 2x?
What
How do I get rid of this 2x?
you would subtract 2x from it.
Right. 2x from both sides. What about 11? How do I get rid of that positive 11?
You would subtract it from both sides.
Right. So you would have to subtract 2x from both sides,
Mm.
and you would have to subtract 11 from both sides, like this. But I put that negative 11 underneath 18 because these are like terms, right? And negative 2x underneath this negative 4 because these are like terms. So you need to combine these, combine these. Does that make sense?
Yes.
Okay. Now we got three more questions, I believe. Three or four. Oh, four more questions to go over. So we're almost there. Okay, this one I think that you did it already. But what I need you to do, okay, so let's try this 16. And then I try to change this into the exponent where it is fraction. What should be the numerator?
3,
3, very good. And denominator?
4.
4, very good. And can you put that in a calculator? When you put this in a calculator, you can do like 16 to the, and then 3 divided by 4 within the parentheses.
16. 2,
Did
2,
you find to the like
3.
raise button?
Mm-hmm.
Okay.
Wait, no. Mm, 3. Wouldn't it? I don't know because
Okay. Let me show you. I Google calculator and I put 16, right? To the, and to the button is right here. To the, and then 3 divide by. Okay. So this is a problem because if I do that, already like divided by just sound and sign is like off, right? So I gotta do it like open parenthesis and 3 divided by 4 and then close parenthesis. Okay. Then hit button and then I'm going to get the answer. Okay. Can
okay.
you, okay, so that gave me 8. So you need to use calculator to do that again. Can you try it on your own and see if you get 8 as well?
I got 8.
Okay, very good, very good. So do the same thing with the rest of this question, okay?
Mm-hmm.
And there are 3 more. Okay, this one. It's not that different. Only thing that you need to remember is, look, how do I change this? Cube root of x to the second power.
Wouldn't you? Have to cancel the cube. No, the cube root out.
Cube root out. Okay. What do you mean by that?
Uh,
So the base is going to be x. Okay, before we get to that part, what do I do with this 2?
you would leave.
You would leave it. You would leave it because 2 is not the base. It's just numbered separately there. Right. And x to the, I'm going to change it into the exponent. Which one should be the numerator?
2.
2. And then divided by,
I'm gonna go with 5.
oh,
It,
it's, you can't see the number over there. It's 3. Yeah, it's 3. But yeah, the number outside has to be in there, like in the denominator. Let me make it larger so you can see it better. Is it better or still better?
that's better.
Okay. What about the denominator? Denominator can be tricky because
It would be x and then 1 over 6.
very good. But where'd you get the 1 from?
It's from the numerator because if a base doesn't have an exponent, it's automatically 1.
It's automatically invisible 1. Very good. Okay, the next step from here is I'm trying to simplify all the way. Um, the reason why I had to change it into the exponent like this is because now I get to do something. When it's division, when we divide this, what could we do with the exponent? 2 is not the base, so I'm going to leave 2. But what do we do with this exponent?
You would have to subtract it since it's not
Right.
the same.
Right, subtract 2 over 3 minus 1 over 6. That's what we need to do.
Divided by 3, that's 6. So 2 divided by 3. It gave me a decimal.
Okay, so if you're using calculator, it will just give you the estimated value. I think that I need you to do this without calculator, or if you have a graphing calculator, there will be a way, but if you don't have a graphing calculator, we gotta make the denominator the same. How can I make this denominator the same?
Wouldn't you have to find the
Common denominator.
yes, the
What would
greatest
that be? 3 and 6? What would be the least common, like common denominator?
2?
2. What do you mean by 2? How'd you
So
get 2?
wait, not 2. Wait, wouldn't it be 1? No,
1? What do you mean by that?
because since I said 2 before because I was thinking since 2 times 3 gives you 6,
Mm-hmm.
we use that, but nothing times 2 would give you 3. Whereas,
No,
no,
no. I mean, you are actually on the right track by saying 2. We try to make the denominator exactly the same, right?
yes,
And 3 and 6 are different. And like you said, by multiplying 2, you could get 6 if you multiply the 2 by 3, right? So if we were doing that, like multiplying 2 to 3, then we just change the fraction the way it is. So we need to keep the value as it is, meaning that I gotta do exactly the same thing on the numerator as well. So I gotta multiply 2 on the numerator as well.
so it would be 4 to the 6,
Hmm.
and then you'd have
4 over 6, right?
oh yes, and then you'd have 2x 2 the 5 to 5 over 6 power. because
What over what?
over 6 power. Because both of the denominators are 6, you would
Mm-hmm.
keep that. You would just add the numerators, and that would
Right.
give you 5.
Are we adding or subtracting here?
Subtracting, it
So
would give you 4. No,
4.
4 minus. It will give you 3.
Okay, very good. And can I simplify this?
It will give you 2x squared
Square. How'd you get the square?
because 3 divided by 6 is 2.
3 divided by 6. Can you try that on your calculator?
3. It would be, wait, because it gave me 0. It gave me a half.
Right.
Oh,
Right. 6 divided by 3 will give you 2. But 3 divided by 6, which one is larger number? Is it 3 or 6?
6.
6 is the larger number. So if you divide the 3 by 6, then it's going to be something less than 1, which is, like you said, half. Okay? So 7 is 2x to the 1 half. Okay? So the rest of the questions, you need to keep the coefficient, the number as it is, and you would have to change this into the fractional exponent and then subtract. Okay?
Okay.
All right. The last part is going to be really simple, but now this one. Um, okay. First thing that you have to do is change inside of the parentheses into the fractional exponent. So let's start with 32. It says cube root of 32. How do I change it into the fractional exponent? Inside of the parentheses only. What is invisible next to 31?
Oh, 1. So it would be 1 over 3.
Very good. And then that to the 3 over 2. So that to the, so what should I do with these exponents then? Do I add them or do I subtract or multiply?
Don't you have to subtract them?
Okay, why?
Because they're not the same.
They're not the same. When did we subtract the exponents again?
Oh,
When
but
you
we're dividing, so you would
right.
add the exponent since we're multiplying.
Are we multiplying?
No, you would do nothing.
Okay. This is a power to a power rule. You got 32 to the 1/3, and then outside of the parentheses to the 3 over 2. This is what we just changed, which is inside of the parentheses, right?
Yes.
And you had 3 over 2 outside. So what do we
Um.
do? Yeah.
So now, this part. Now you will multiply.
Yes, you
Am
will
I
multiply. Very good. And what about the second one? 128 to the what power should I put there?
1/7,
Very good.
and then you will multiply that
With
3/2.
okay, it's hard to see, but it says 5 over 2.
Oh,
So just like you said, you are going to multiply them. What is 1/3 times 3 over 2? Let's start with that.
uh, that would be 1/3. Okay, so that would be 2/6, right?
1/3 times 3 over 2.
Oh, that would be 3/6.
Right, very good. It will be 3 over 6.
Okay.
3 over 6. And what about the second part? 3 over 6.
That would be 5 over 14.
5 over 14. Okay, very good. Um, okay, so we're almost there. The questions have not just simplify them, but also we need to answer it as a whole number. So I think now I cannot simplify anymore, right?
Yes.
So what I can do is use now calculator to do this.
Okay, okay. Okay. That would be 32
Yep, let me just go back. Sorry. 32.
to the, I feel like I'm gonna have to put this in parentheses.
Right.
32
Right. You
to
need to.
the 3 close parentheses times 128 to the, ooh, wrong thing, to the 5 divided, close parentheses. That would equal, wow.
What did you get?
I don't think I was supposed to put all that together. So 32, 3 divided by, I gotta, oh Lord. Oh, okay, I see what I did wrong. 3 divided, wait, hold on, because it's not letting me put the,
Okay. All right. So let's try it together. So what did you put again? What are we supposed to put? 32, right?
yeah.
To the and open parenthesis. What was it?
Oh, 32, open parentheses, 3 divided by 6, close
Okay.
parentheses. That would give you 5.65.
Okay. And then that times by 128
And 28,
to the
5 divided
open
by,
parenthesis. 5 divided by
then
14, right?
that will give you 32.
Yes. Very good. 32. So my final answer becomes 32 then. Okay. All right. Last but not least, this question. Um, it might look difficult, but actually it's like simpler than what you just did. So I need you to take a look at the inside. Ignore the outside, but only the inside. It says square root of x plus 2 to the fifth power. What is the base here?
The base is 2 and an x.
Right, this whole thing, x and plus 2. So you need to keep that x plus 2 as your base. So let me just copy and paste here. I just wanted to change the inside, so I'm just going to erase what's inside here, and then I'm going to write down that again. So you said x plus 2 is the base, and
Yes,
now to the, I'm going to put that as an exponent. No, I see 5. I don't see any number. What was the number that is invisible here since it's a square root?
that would be 1. So it would be 5, well, just 5.
Okay. Then what's the difference between x plus 2 to the fifth power and square root of x plus 2 to the fifth power, if that is going to be just 1?
Because
Square root.
because of the square root.
Right, square root. So actually there is a number other than 1 invisible out there. Um, what was that number? Not 1. Let me ask you this question. What is square root of 4?
4 times. That'll be 16.
That's squared of 4. Square root of 4.
It'll be 2.
Right, 2. What is 2 squared?
4.
4. So you can see that square and square root is like the inverse operation, right?
Yes.
So whenever you have square root, that means that there is invisible 2 out there.
Mm.
Okay? We
So
make that 2 invisible.
so
So
it
it
was
was 5 over
2.
5 over 2. Okay? Now what I'm going to do next is change what's outside now. Okay, so this is cube root, and I know that there must have been like invisible 1 out there, right?
Yes.
Right, so, well, let me go back. And, okay, so how do so I had x plus 2 to the 5 over 2, and what should I put next to that?
1,
Over
3.
1 over 3. Very good. And what do I do with those two exponents, you think?
You would. Wouldn't you multiply? No. You would multiply them because you're going to keep your base the same.
Right. And this is like a power to another power that you have. Like if you have exponent right next to each other without any base, without any same base, then that means that you need to multiply them. Okay? Does that make sense?
Yes.
Okay, so times by 1 over 3. Okay. What does that give you?
Okay, so it would be 5 to the 6th power. Well, 5,
5.
6. Yeah.
Right, 5, 6. Very good. Yeah. So your final answer will be x plus 2 to the 5 over 6. That's it. Okay?
Yes.
All right. Very good job. You went through all of that. You're the only one. Okay. So that means I'm going to share this with you, and you can take a look at this as you work on your own assignment. And once you finish, just hand it in to me. Either you
Okay.
can write on a paper. Which one would you prefer? Would you do it on your paper or you're gonna do it on the Google Doc?
I do it on paper.
Yeah, yeah, because it's taking me forever to write these answers. I think that it will be a lot easier for you to do it on the paper. All right. So I'm sharing that with you, so it should be okay.
Yes.
All right. Thank you, Diamond.
Thank you, Miss Park.
No problem. My pleasure. Bye. Have a great rest of your day.
You too.
Thank you.